Hi, I'm Steve Sweeney. The video you're about to watch is the fourth in our Understanding Email series, tutorials that explain how email works. In today's video, we'll cover how email depends on domain name services for delivery and filtering. If you find this video useful, please visit our website, www.fsl.com, to access other software, documentation, and references that make administering email systems easier. So let's get started. Domain name service, more commonly referred to as DNS, provides the underpinnings for the Internet. So it should come as no surprise that if DNS fails, email delivery fails. But before we look at how DNS and email work together, let's review what DNS does and how it came about. Since the first computers weren't networked, they didn't need names or numbers. And the early networks used different competing network schemes, so they also used different naming schemes. But all of the different schemes had one thing in common. The addresses that the systems on the network used to identify and route data were based on numbers. While computers like numbers, we find names a lot easier to remember and use. So early networks used a host.txt file that mapped the computer's name to its network number. That host file was virtually identical to the host files that are used by computers today, except the original host file had the name and address of every computer on the network, and every computer downloaded this file every night. In the 1980s, there were over 10,000 hosts in the host.txt file, and the process became unsustainable. So in 1983, John Postel and Paul Makapetris invented the domain name system and wrote the first application that provided DNS services. In 1985, the Berkeley Internet Name Domain, or BIND server, was released. By the time BIND was ported to the Windows NT platform, BIND and DNS, along with the numbering scheme it supported, had become the glues that held the Internet together. And that scheme is still in use today, but we're running out of numbers. The original numbering scheme, designated IPv4, was a 32-bit numbering scheme which allowed for over 80 million unique addresses. This seemed like a lot in 1980, but on February 3, 2011, the last batch of 5 top-level address blocks were assigned to the regional Internet registries, officially depleting the global pool of completely fresh blocks of addresses. The solution to this problem is the IPv6 numbering scheme, a 128-bit addressing scheme. This will allow everyone alive today to have a little over 4.8 times 10 to the 28th power personal IPv addresses. The following types of DNS records are used by email applications. A DNS Type A record maps a fully qualified domain name, commonly referred to as an FQDN, to an IP address. A DNS Type PTR record maps an IP address to a fully qualified domain name. A DNS Type MX record, or mail exchanger record, maps a domain name to a list of hosts that will accept email for that domain, along with a number that shows the order in which the delivery to the host should be attempted. This is the record that makes email delivery to individual mailboxes possible. Your mail server sends the message to the mail server for the recipient's domain, and that server knows how to deliver the mail to the right electronic mailbox. Two other types of DNS records are used by mail delivery systems to help detect spam and forged emails. An SPF record is a text record that a site administrator can create to specify exactly which servers are allowed to send email for a domain. And a special type of PTR record has been created to allow anti-spam systems to quickly check the reputation of an IP address, hostname, or a URI and see if it is in use by a spammer or other criminally controlled site. We'll look at both of these records in more detail shortly. But first, let's look at some examples of typical DNS records. A DNS lookup of the fully qualified domain name returns the IP address. A DNS lookup of the IP address returns the fully qualified domain name. A DNS lookup of the domain for a Type MX record returns a list of hosts that will accept email for the domain and a number that indicates which is the preferred server. A DNS lookup of the domain for a Type TXT record typically returns the SPF record if one exists, and a lookup for a specially formatted A record against the DNS real-time blacklist returns an IP address that is a code which indicates if the data is listed in the RBL. When your Mail Hub starts to send your email, the first thing it does is to look up the MX records for the recipient's domain. Once it has this information, it tries to establish a network connection to the preferred MX server. Once the connection is made, the receiving MTA has the IP address of the sender. This IP address is about the only thing in the email transfer transaction that cannot be forged. The receiving MTA immediately does a DNS PTR lookup to get the hostname of the connecting server. SPF records, if they exist, will tell if the sending host is authorized to send mail for the domain of the sender. Note that publishing SPF records is not required, but I strongly suggest that every domain that sends email publish SPF records. It's the only way to prevent a scammer from forging emails that appear to come from your domain. And once the message is accepted, most sites apply some type of spam filtering, and most spam filtering applications today run checks that employ DNS checks against real-time blacklists. It's not unusual for an anti-spam application to make 20 to 40 separate DNS queries while processing a single message. In fact, when mail delivery slows down, the first thing to check is the speed of the DNS queries. For more detailed information on creating and using SPF or Sender Policy Framework records, please visit the openspf.org website. And for a detailed explanation of how DNS real-time blacklists work, please see the Wikipedia entry for DNSBL. This concludes the fourth video in our Understanding Email series. We hope you found the video useful. If you have any comments or suggestions, we'd love to hear them. Please send them to comments@fsl.com. Please visit our website to access other videos in the Understanding Email series, as well as other information regarding administering email systems. And thanks for watching.